Hello, hello. Am I audible? Tell me in the comment section. Is my voice is clear? Tell me in the comment section. Is my voice is clear? Okay. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good in your studies. So let's again resume our chapter, that is magnetic moving charges and its magnetic effects. Okay. So till now what we have studied about forces. Now a little bit about, we have the idea about forces, how what kind of trajectory we have for different things. Circular trajectory actually we are going to take here. Helical path, what kind of helical, what is called as helical path. About radius and these kind of things will be we are going to study, and I hope that my voice is pretty much clear to you. Once tell me everyone in the comment section. Okay, I hope that it is very clear to you, all of you. Okay, fine. So let's without wasting any further time, let's begin. Let's start some learning something new. So be ready with your pen and paper. Okay, first thing is, in the starting, in the first line of the last lecture, that in the last lecture I have told you about, the last lecture I have told you that magnetic force never changes the velocity, and this is a very important point that you have to understand about magnetic force. It has the property that it never interfere with the velocity portion. Okay, so with due to that, what I can say, understand here, if I am talking about the work done, work energy theorem, if I am applying, what I will say, let's suppose some magnetic force is acting on it, and it will initially it is having some velocity v. But I will say work done by magnetic force is equals to K final minus K initial. This is what work energy here, correct now? Final situation I am saying, and this is the initial situation I am assuming. Final velocity, how I will be writing final velocity? Half mv square. And what is the initial velocity also I am writing? Half mv. So because the reason is what? Magnetic force is acting. And if magnetic force is acting, velocity is never going to be changed. So initially also velocity is v, and finally also velocity is going to be v. So what I can say about the work done, can I say this will be cancelling out each other, and the total work done by magnetic force is equals to 0. This is a very important point that you have to understand, that the work done by magnetic force is always equals to 0. Is it clear? Very obvious thing also. Okay, very obvious thing. It is not something very new. See, path of charge particle in a uniform magnetic field. If there is a uniform magnetic field, what kind of path you will be having? If you are giving some velocity to any charge particle, it will start performing a circular motion. It will start performing a circular motion, and who will be acting as a centripetal force? Because if there is a circular motion, of course there will be mandatory to have some centripetal force almost. So tell me, who is having the centripetal force here? Can you say magnetic force? Check kar lo, direction check kar lo. This is the velocity v that I have given. Take your hands in the direction of v. What is the force? Q v cross b. That means v cross b basically I have to do. Now I have two options, either this way, either this way. You tell me which way I will be doing. First way or second way. I will be showing my palm to magnetic field. This is the magnetic field that is coming outside the plane. Magnetic field. What is the direction? This one. Here what is the direction? Here what is the direction? That means it is always acting perpendicular to the motion. That means it is going to perform a circular motion. It is very clear. Okay. So if it is going to perform a circular motion, what I will be writing? I will be writing that QVP, that is a magnetic force, is acting like a centripetal force. And what is centripetal force? Centripetal force is mv square by r. So from here, if I have to calculate the radius, that is one of the most important formula. Here radius, what I will be writing, students? Radius I will be writing simply r is equals to, here anything is getting cancelled out? No, I don't think so. It is v and v square will be simply get cancelled out. And what you can say about the radius? Radius can be written as mv divided by qb. mv divided by qb. This is what I can say about the radius. This is what I can say about the radius. Correct now? Now, if you can say about radius, a lot of things also you can calculate from there. What are the other things that you can say? R is equal to mv by qb. So what you can say, R is equals to mv. Mv can be written as momentum mass into velocity divided by qb. And momentum can also be written as, in terms of kinetic energy, it can be written as root under 2mk divided by qb. All these relations are actually valid, root under 2mk divided by qb. Momentum is mv, and here you can see the same result can also be written as like this. If someone asks you, tell me what is the time period, how will be saying? What is the time period? Correct. Tell me, how will be writing? Time period. Time period means what? How much time is it is taking to complete one complete rotation. Time period can be written as, what is the total distance you have traveled, students? 2 pi r, correct, and divided by what is the total time velocity that you are having, constant velocity v, correct, not velocity, constant speed you are having, velocity is constantly changing, okay. And here what you can say further, 2 pi divided by v. What is the radius that you are having? 2 pi r. R is equal to mv divided by qb. Velocity cancel. From here you will have a formula for time period, that is equals to 2 pi m divided by qb. Time period is equals to 2 pi m divided by qb. This is also one more very important formula that you have to remember. Clear? These are some basic things that you can comment from here. Okay. Kinetic energy, one more form in terms of potential. Kinetic energy or any energy can be written as Q into delta V. This is also one thing. Here time period is equal to 2 pi m divided by qb. Already I have explained to you. Correct now? Same. If you know about the time period, can't you say what is omega? What is omega? Omega is equals to 2 pi f. From circular motion you are understanding this formula. So frequency can also be written as 1 by time period. So 2 pi divided by time period is equals to omega. 2 pi divided by, what is time period? Time period is nothing but 2 pi m into qb. 2 pi cancel. What will be the omega? It will be equals to qb divided by m. qb divided by m. This will be the formula. Clear? Any doubt in these derivations? All these things are pretty much clear to you. Okay. Here you can read, it is given in NCERT that what is the reason behind the northern lights. It is very interesting. What happens? Actually, some very high energy charges are coming out of the sun. Okay, out of the sun, and Earth have this kind of magnetic field lines from north to south. So due to that, due to this orientation, all these high charge electron charges gets collected on the northern and the southern side. Okay, here it is stored. And what happens due to this atmospheric energy that you are having, due to atmospheric gases, they gain some energy from there. From this atmosphere, they gain some energy and then lose energy. Due to this gaining and losing of energy, actually you due to this loss and taking or giving of energy, you can say there is some phenomena. Due to this phenomena, there are some lights that are sparkling here due to that losing and gaining of energy. And that light is the phenomena that we call as northern lights, that we define as northern lights. That is very rarely, but it is visible to some people. Okay, and it is marvelous. It is defines the beauty of nature, how beautiful our nature, and this is the physics that is present behind that. So you know that behind everything there is physics. So you know the importance also of physics. Cool. So tell me, now we'll have some different kind of questions. Now we'll be entering our charges into magnetic field, not for the compute section, at some specific points, and we will be analyzing what is going to happen with our charges, how they are going to move, for how much time they are going to move, how much angle they are going to cover, all these things. And this actually makes a very good variety of questions as well in the competitive exams, I am telling you. Okay. So let's see the first case. We'll be starting from the basic cases here. Okay. So what is the first case? Our omega is constant, okay, and it is less than a semicircle. What will be happening? Why I am saying that it will be less than a semicircle, and what is happening? Listen here. See, I have given a charged particle some velocity v. I have given some velocity v. Correct. Now what will happen? Tell me what will be the direction of force. Firstly, find the direction of force. V cross B. V is inside the board. That means I will have this kind of direction. That means I can say this will be acting like a, this side will be acting like a center point. Correct? This will be going to behave like a center point. Now, if the question is asking you, tell me how much time you are inside this magnetic field, because what kind of trajectory it will be following. Circular motion, and circular motion will be somewhat like this, and here it will again exiting straight away, correct? So this is what I have to do. So how I can say, I know that whatever the angle traveled, this is the angle that is covered into this magnetic field, because this is going to behave like a radius, this is going to behave like a radius, and this is the circular path that it is going to follow. So I can say whatever the angle followed, theta is equals to omega into t. Theta is equals to omega into t. Now how you can write time? Time can be written as theta divided by omega. Theta divided by omega. Now tell me, what is omega? Omega is nothing but QB divided by M. Just in the last slides we have checked that omega is equal to QB by M. Okay. Now that means basically you have to write only Q. Yeah, I should remove this from here. Okay. So basically you have to write QB by M, and what is the net angle that is traveled into this magnetic field? This is what the question is asking you. Okay. So now by doing some construction, what you can say, let's suppose if this angle is theta, if this angle is theta, from the from the horizontal, this angle is given as theta, and for this velocity I can say force is always perpendicular to the velocity. So what I can understand from here, if this angle is theta, what I can say about this angle will be nothing but 90 minus theta, because this and this are perpendicular, that means this angle I am going to say 90 minus theta. If this angle is 90 minus theta, what I can say about this angle, angle will be again become theta. And if this angle is theta, I can say this angle is also theta. Now you tell me what will be the reason. Tell me what will be the reason why this angle is also equals to theta. No, those students who got this reason, please comment down in the comment section. I will be checking all of your comments. So this angle and this angle will also become theta. Now from this, what is the sum of a triangle? Sum of a triangle is theta plus this angle, let's suppose theta dash is equals to pi 180 degree. That means theta dash, I can say how much? It is equals to pi minus of 2 theta. Theta dash is equal to pi minus 2 theta. This angle will become pi minus 2 theta. Correct now? So what I can say about this angle that is covered, swept into this magnetic field, it will be subtended angle is equals to pi minus 2 theta. This is the result, and this eventually it will become the total time that is covered into the magnetic field. Now it depends on the question what they are asking. This is the general thing that I have to tell you. Clear? Now check this one. Again omega is constant, but we are not making it at some different angle. Okay, let's see what we are going to do. This is the velocity at which I have thrown this, and from here the magnetic field also starts, and this is inside the plane. It is clear from the diagram only. Okay. Now firstly find out what is the first step. Firstly find the direction of force V cross B. What is the direction that you are getting? Can I say this is the direction that you will be getting for the force? That means at this point it is going to behave like a center. And I can say what kind of trajectory it will be. It will be a circular trajectory between both of them, and this will be looking like, and from this point again it will be exiting this magnetic field, and let's suppose this angle is we will be calculating that angle also. This is what the trajectory will be. At this point if you are calculating this centrifugal force, again it will be coming, actually the magnetic force, again it will be coming towards the center only. Check V cross B. What is the direction that you are getting? Again towards the center. Correct now? Now see, again the concept will be angular displacement is equal to omega into t. That means the total angle that you have covered is equals to omega into t. And what is omega? What is omega, students? It is equals to QB divided by M into t. Now you tell me what is the total angle that is swept inside the magnetic field. See, at some angle theta you have projected it. If you have projected it at some angle theta, what you can say about this one? This one will be, let's take a different color. If this angle is theta, you can say this angle is 90 minus theta. If this angle is 90 minus theta, you can say this angle is nothing but theta. If this angle is theta, this angle is theta. Again, the same, by the same property, the students are going to tell me in the comment section that what is this property. How I have said that this angle and this angle are both are same. If this angle is theta, what I can say this angle, because these two are perpendicular, that means this will be 90 minus theta. If this is 90 minus theta, what I can say about this one? This is again going to be theta. Correct? Now apply the sum of a triangle, this theta, and that means this will become pi minus 2 theta. If this is pi minus 2 theta, this total is, let's suppose this angle is some theta dash, the actual angle that is swept. So I can say theta dash plus of theta is equals to 2 pi. That means theta dash can be written as 2 pi minus of theta. Theta can be written as pi minus of 2 theta. That means what you can say, it will be nothing but equal to pi plus of 2 theta. That means the total angle that is swept is equal to pi plus of 2 theta. That means what is the time that is spent in the magnetic field is equals to pi plus 2 theta into m divided by qb. Now tell me, is it clear or not? Is it clear? Easy, correct? Basic things we are following. We are just checking what is the total angle that is swept inside the magnetic field, and then we are writing just theta is equal to omega into t. Correct? Now here the question is asking you the angle at which charged particle exits the magnetic field. Let's suppose at any general angle. How we will be drawing that? Let's see also. This time I am not giving you some sufficient space so that it can come back. What happened? This much. This is the only range for this magnetic field, and the distance given is d. So it is not a sufficient space to take a complete U-turn and come back again. So in between it is going to exit the magnetic field, and you have to tell me what will be the angle at which it is going to exit. So how we will be calculating that? Firstly, check what you can say about, let's suppose it is entering at some velocity v here. What you will say? V cross v. What is the direction that is getting? This is the direction that you are getting. That means it is going to perform a circular motion in somewhat this kind of way. And this is the center where you are taking. That means this is the radius, this is also the radius. And I am assuming at some angle theta it is going to exit from this magnetic field. What I will be saying? If this angle is theta, this angle is 90 minus theta. If this angle is 90 minus theta, what I can say about this angle will be theta. If this angle is theta, what I can say about this angle is also theta. Exactly what I have to calculate? I have to calculate this angle theta. So can't I calculate from here only? Easy. What I will be applying? Define sine of theta here. Sine of theta into this triangle. So what is sine of theta? Perpendicular upon hypotenuse. What is the perpendicular distance? You will say d. And what is the hypotenuse? R. So if I will ask you theta, theta will be equal to simply sine inverse d by r. Now I will not say that to remember this result. It is a very obvious common sense result that I am telling you. So even if you are not remembering, there is no harm into it. You can derive it easily. There is no problem. Clear? Now there are three kind of cases. What will be happening in all these three cases? Depending on the distance d. If this distance d is less than r, that means you have not given sufficient distance to take a complete circle. If you are stopping in between, what will happen? It will not be able to complete a circle. It will exit on the other side of the magnetic field. Same is written here. Particle will exit magnetic field at an angle emergence that we have just calculated and follow trajectory with that angle after exiting the field. After that, it is going to be straight path. If you have given just d is equals to r, just that much of that, it is taking a U-turn. At that point only you have given that exact distance. What will happen? It will exit straight away from that distance. What is a particle will exit the magnetic field at 90 degree and will move tangentially to the magnetic field. Exactly, let's suppose if I am trying to tell you, this is the particle that is coming and it was just about to take a U-turn from here. This will be the radius. So what will be happening? It is just about to take a U-turn, but you have exited the magnetic field. That's why it will exit from the magnetic field at here only tangentially to the magnetic field. If you have given the sufficient distance on the first two cases, already we have seen that it is going to complete. It is going to come out on the same side of the magnetic field. That means if there is some sufficient distance, it is going to cover, and again it is going to come out from the same side of the magnetic field. Correct? All these three cases are clear to you. Fine. Now try to solve this question. What this question is asking you. Let's see. See, what is the question is saying? A neutron of kinetic energy 50 kilo electron volt is describing a circular orbit of radius this much in a plane perpendicular to the magnetic field. The kinetic energy of the proton that describes the circular orbit of radius 0.5 meter in the same plane with the same magnetic field. You have to tell what will be the kinetic energy of the proton we have to tell me basically what will be the kinetic energy of the proton. How you can relate? What are the values that are given? They have given you about radius. They have given you about neutron and proton. What is the relationship between them? Do you know? And they have given you about the kinetic energy. Radius, kinetic energy. How you be relating? Tell me. R is equals to root under 2m kinetic energy divided by Q into B. Correct? Can we, can I say, is it true to say that radius is directly proportional to root under m by k? Correct? Because the charges on proton and neutron is same. Only the mass difference will be coming. Okay, and you know about the relation about that. So you will say that radius of proton divided by radius of deuteron is equals to root under mass of proton into kinetic energy of proton divided by root under mass of deuteron into kinetic energy of deuteron. Now this will become equals to 1 because the radiuses are given same. That means here what you will be saying, mass of proton can be written as mass of proton into kinetic energy of proton. Tell me kinetic energy of proton. 50 is equals to mass of deuteron. Mass of deuteron is how much? 2 times of mass of proton into kinetic energy of deuteron. This will simply get cancelled out, and what you will say kinetic energy of deuteron, that will be 25 electron volt. Exactly 25 kilo electron volt. That will be the answer. Clear? Once again, did we made a calculation mistake? Correct. So this was clear to you. Now come to the next question and try to solve it. What is the question is saying? Subhasa is making a raid into our class. Okay, we don't want that the students will be learning peacefully.
No sir, I am not doing that because simply I came here. What are you discussing, sir?
Just simply a question, sir.
Which topic, sir?
Magnetism, sir.
Oh, my favorite topic.
tell me.
Okay.
Can I ask you something?
Sir, this question can I give the answer?
If you can, then give, no problem.
Okay. What is the question? A uniform magnetic field acts as a right angle to the. Oh, Fleming's rule you are discussing.
No.
This one I do. I only know this one, sir.
In this question, you don't have to tell what is with the direction.
What a uniform magnetic field acts as a right angles to the direction of a motion of an electron as a result. The electron moves in a circular path of a radius 2 cm. If the speed of electron is double, then the radius of the circular path will be remaining same.
Wow.
I don't know, but answer is remaining same.
No.
No. Then option D.
Option
D.
D. Let's check it.
Let's check it.
Option B.
Oh.
Why now, students? Tell me what is the reason? Okay.
Okay, guys. Okay, carry on, sir.
Thank you.
Thank you, sir.
Now we will be doing a raid in chemistry class, and let's see what is happening. So tell me, students, what was the reason why it got double? Actually, we know the formula of radius. Radius is equal to simply what? mv divided by qb. What is radius? Radius is equal to mv divided by qb. So what I can say about the radius? Radius, if the velocity gets double, I can say radius is directly proportional to velocity. So if the velocity gets double, radius will also become double. So simply I can say what will be the answer? It will double to 4. Correct? You can check the calculation part of the last question. Okay, but that will be the 2 factor. Either it will be divided, either it will be multiplied. There is no issue in that. Solve this question. What is the question? An electron having mass m and kinetic energy E enters in a uniform magnetic field and we perform what then its frequency will be. What will be the frequency? How will we calculate frequency, students? What is time period? Time period is how much? Time period you can say it is 2 pi r divided by velocity. Correct? 2 pi r divided by velocity. And how you write this radius? Radius is written as 2 pi is into mv divided by qb divided by here velocity is v. Correct? So if you have to write its frequency, what you have to do? You have to just make the reciprocal of this thing and then just check in what terms the answers are given. Just check from there and you will be having your answer. So what you will be doing? frequency, if you have to calculate, just make this reciprocal. What you'll be getting, V into QB divided by 2 pi into mv. If I'm cancelling this term, velocity, what will be there, QB divided by 2 pi m, and Q can be substituted as EB divided by 2 pi m. That means which option is coming correct? B option is coming correct. Is it clear? Here B option is coming correct. Clear? This is not the part. Now let's enter into the next section of this chapter, that is magnetic dipole. We have studied in complete depth for electric dipole, and now we are entering into the section of magnetic dipole. Most of the formulas will be remaining same. Some new things will be introduced that I am going to tell you. What was electric dipole? Electric dipole was two charge Q1, Q2. Okay, no, actually the magnitude was same, but the polarity was different, and it was separated by a small distance d. What is the magnetic dipole and what was the electric dipole? There you have written. You have written it's equal to Q into the distance between them, Q into d. Correct. Now here, what are the terms that I have to tell you? Here the terms that we will be introducing is, here north and south pole is there. We will name this as M. At the place of charge in plus Q minus Q. Now what we are going to represent? We are going to represent it as a plus M, not actually plus M minus M. It is represented as M. And what is that? Here, what is our magnetic dipole from negative charge to positive charge? Electric dipole is equal to Q into D. That means how we represent magnetic dipole, it is represented as capital M. First thing you have to understand is equals to, at the place of charge, what we represent here, small m into the distance between them. Here the distance that we have taken is, that is equals to 2L. This is the representation. Capital M is equal to small m into. Now what are the terms, sir? Terms that we are using here is, this capital M is called as magnetic moment. This small m, what is this small m? This small m is called as pole strength. This is called as pole strength, and this is what the distance between them. Simple as that. Correct. This is what the pole strength. Now here also you have been represented what is the direction for electric fields. Okay, here it is a comparison that is given for you for electric field. P is equal to Q into 2L. What is the electric field? And we are making an analogy in magnetic field. A lot of formulas are remain same from magnetic field to electric field. Lot of formulas are remain same here also. Here it is shown for you that what is the direction of magnetic field lines also. It is for inside point, if you will be looking, it is looking like it is going from south to north, and for outside point it is going from north to south. This kind of loop is there. Okay. Now there is a very big doubt if I will explain you what student usually thinks, because any kind of bar magnet, if you are taking, it will have its north pole and its south pole. So what will be happening if I am breaking this bar magnet from the middle? So students will say that, sir, this will be completely north pole and this will be completely south pole, but incorrect. It is not at all possible. Magnetic monopoles are not possible. What is monopole? The small m that I have represented, those are representing monopoles. So it is not practically possible for a magnet to have a monopole. Monopole means there are not two poles, different poles. When you will be breaking this now, then what will be happening? This will become south and this will become, eventually automatically it will become north. If you are then again breaking it, again it will become north, south, then again here it will become it was south, it was north, and eventually it will be going further. Correct? This will be happening. So magnetic dipole, magnetic monopole doesn't exist. This is the important point that you have to remember. Direction of magnetic field, already I have told you what is the direction of magnetic field. Here it is very clear to you. Now the next thing is magnetic moment and how to calculate magnetic moment. This is an interesting thing. A formula that you have to remember is magnetic moment is defined as current into the area. and area is a vector quantity and current is a scalar quantity, so the product is going to give you again a vector quantity. So magnetic moment is a vector quantity, that is what we have to remember, and it is a very important thing. Why and how to calculate that also we'll be discussing. See properly, okay, because this is a little bit of 3D things will be coming, so I will be trying to explain it properly, but with me also you have to focus properly. Okay, so let's see how to understand magnetic dipole, actual magnetic moment. See, this is axis, three axes that are drawn: x axis, y axis, z axis. Tell me, this page is kept in which axis? This page is kept in which axis? If I am giving you, can I say this is in the board plane? This is x axis, this is y axis. Tell me where the area vector is going to come. Always magnetic dipole follows the area vector. Whatever the direction for area vector will be there, it will be the same direction for magnetic dipole, magnetic moment also. Correct? So if I am asking you, tell me what will be the direction of the magnetic moment, can, or area vector also? I can say area vector will be coming out of the plane. That means in which direction? Can I say positive k direction? So when I will be writing magnetic moment, I will be writing what? I into area vector. Current is I into area vector. What is the area vector you will be saying for here? Area will be a square and the direction will be k cap. This is the magnetic moment you will be saying. There is second way also. Curl your hand in the direction of current. Curl your hand in the direction of current, anti-clockwise direction. What is the thumb? Where the thumb is going? Outside the plane. That means positive k cap. Positive k cap. Is it clear? Come to the second one. Here you are watching that what is the plane in which it is kept. This kind of plane it is kept. The paper or anything is it is kept. Now what? Where the area vector will be going? Can I say area vector will be perpendicular to it? Area vector will be perpendicular to it. So where the area direction, the vector is representing you, x axis. That means how you will be writing magnetic moment for this case? You will be writing I into again a square, but the area vector will be representing for positive of I cap. Or also curl your finger in the direction of current, you will be having again I cap. Okay. Here again, here it is kept in x z plane. If it is kept in x z plane, it is going to give you the area vector in the j cap, positive j cap. That means what is the magnetic moment, students, you are going to write for this case? You will be writing current ai into a square multiplied by a j cap. Correct? This is what we are going to attempt, and let's see some other cases also. Let's suppose this time you are having two directions, then how will be writing? If you are having two directions, let's suppose here this case, here is a plane. Tell me what is, here it is a kind of wire is kept in xz plane, okay, and it is subtended further in yz plane. Now tell me what are the area vectors that you are going to get. First area vector you will be getting for this one, correct, for this, and second area vector you will be getting from this one. Let's suppose name this as a1, this as a2. That means in these two directions again you are going to get area vector. How will you be writing the magnetic moment? You will be writing I a square. Firstly, due to this, what is the direction that you are going to write? Plus of j cap. Due to the second one, what you are going to write? What is the direction that you are getting? Plus of I cap. So this will be the final result. I a square j cap plus I a square I cap. I a square I cap plus j cap. That is the same result that we have to understand. Is it clear to all of you? Now see here. In the next case, in the fourth case, I guess it is the fourth case, they have given you at some angle theta from the x-axis. So make it in your own way. I am removing this for a moment. Okay. Make it in your own way. Make a component here of this plane. What will be the component? What will be the length that you will be having here? If this is a, and make a plane here also. This will be what? A cos of theta, and this will be what? A sin of theta. This is what? A cos of theta. This is what? A sin of theta. Now can you say, now easily I can do this? Now easily I can do this. How I will be doing? This is B, this is A. B is going to be same. How I will be writing the magnetic moment? I will be writing. Tell me what is the area? Area I am writing current into A into B. For this one, this YZ plane, I will be writing AB, B is sin A sin theta. And what where the area vector is going to be in I cap plus again I into AB. This time it is cos theta, and the where the area vector is going to come, k cap, I cap, k cap, sin theta. Okay. What is the direction of current? Draw that also. Yeah, it is the direction of current. That means it is coming like this. Now curl your hands. Check where the direction is going to come. This is going to come. This in this axis is going to come in positive x direction, and here again curl your direction. That means this is the direction of current for this axis. Again curl your fingers. What is the direction that you are getting inside the plane? That means it will be minus of k cap. That's why they will be having a minus of k factor as well. Clear? Just curl your hand in the direction of the current. You will be having easily all of your directions. Correct? This is about magnetic moment. Now see, there is a relation that you have to study about magnetic moment and the rest of the things. See how you can say what is magnetic moment. How you have defined magnetic moment? Magnetic moment is defined as I into A. Correct? It is defined as I into A. And how you can define current also? Current can be written as dq by dt. Current can be written as dq by dt. So it can also be written as charge. If I am focusing on a single charge, I can write it as E divided by T. E divided by T. And time already I know that I can write it as EV divided by 2 pi r. EV divided by 2 pi r. That means eventually I will be putting the time is equals to 2 pi r divided by V. So now let's write it. What is the current that you are writing here is EV divided by 2 pi r into area. Correct? That means you will be writing here, and area is equals to how much for this cross section area? You will be writing EV into pi r square divided by 2 pi r. Pi cancel, r cancel. What is the same? EVR divided by 2 pi. EVR divided by 2 pi. And now tell me what is momentum? What is momentum? Momentum is equals to, so momentum is equals to, if you know the formula, momentum is equals to mvr simply. Now if I have to make a relation between magnetic moment and momentum, what I will do? I will multiply here simply m and divide also by m. And what is mvr I am going to write? I am going to write it as momentum, that is L. This is magnetic moment is equals to m divided by 2 pi m. Divided by 2 pi m. And here in the numerator also I will be writing, I think that I missed a factor, that is equals to E. Correct? That means from here, if I will concluding, I can write m by L is equals to charge, that is E divided by 2m. M by L divided by 2. This is a very important result that you have to remember. M by L is equals to charge divided by 2m. On the basis of this, a lot of formulas you can derive also. For example, if I have to tell you on basis of this what you can do. See here. From this, what you can say, this is a relation that you already know, magnetic moment and angular momentum, and when you will be taking the ratio of any kind of things, it will always be coming is equals to Q divided by 2m. See, for example, for this one, see, for let's suppose there is a uniformly charged rod, okay, and you want to calculate what is the magnetic moment. For uniformly charged rod, how you will be writing? You will be writing it as Q divided by 2m into L. L is what? The magnetic moment. Now write Q divided by 2m will be as it is. Momentum, angular momentum can also be written as I into omega. There is a formula that I hope that all of you will be knowing. I into omega. Tell me what is the moment of inertia of a rod about its end point. About its end point, what is the moment of inertia? It is ml square by 3. That is I into omega. Now check what are the things that are getting cancelled. M simply get cancelled. And what is the result that is left? Q omega L square divided by 6. Check. Q omega L square divided by 6. This is the magnetic moment for a rod rotating about its end. Correct. Let's see the another one also. Let's suppose what is given here, hollow conducting sphere. Hollow conducting sphere, again you are going to do the same thing, q divided by 2m into magnetic moment. Magnetic moment can angular momentum can be written as I into omega. Q divided by 2m into, tell me what is the moment of inertia of a hollow conducting sphere. Hollow conducting sphere, what is the moment of inertia that you can write here? It is equals to 2 by 3 mr square into omega. M will get cancelled. Here you can write it is equals to 2 also get cancelled. That means q omega r square divided by 3. This is what the result that you will be getting. Is it clear? You can even write for solid also. Non-conducting disk. For a disk, how you will be writing? M is equals to q divided by 2m into q divided by 2m into angular momentum, that is I into omega. Now just write q divided by 2m into I. What you will be writing? I mr square divided by 2 into omega about this axis. Now what will be the thing? M simply get cancelled. Final result will become q omega r square divided by 4. Same you can write for non-conducting sphere, that means for solid cylinder 2 by 5 mr square, and the final result you will be getting somewhat like this. Is it clear? From a single relation m divided by l is equals to q divided by 2m, it is very important result. Again I am saying it will be helping you a lot of places in solving the questions. It will make the questions very simplified. Is it clear to you? I hope that you have liked this lecture. Okay, you have learned something new. So until next time, keep learning, keep growing with tapasya, endigu and then digu nama tapasya.